All right, exponent rules. Let's take a look. So remember with the exponent rules, don't memorize, just think about what this means. Like, what does this mean? This means n times n times n times n, that's 5 n's, times n times n. How many total n's? N to the 7th. This means, what does this mean? This means n 5 times, and then that multiplied by itself twice. How many total n's there? Oh, that's 10 n's, right? That's 5 n's and 5 n's, so that's this, n to the 10th. What does this mean? This means 5 n's over 2 n's. Well, what happens? This is n divided by n, that's 1. N divided by n, that's 1. What am I left with? I'm left with 3 n's. Okay, and then lastly, what does this mean? Okay, this means I'm not happy in this part of the fraction. So we imagine this as a fraction, and we say, oh, this is this, n squared over n to the 5th, right? Now, look, see this negative 5? It's a positive happy 5 down on the bottom of the fraction. So this is this, and it's kind of like the reverse of what we just did here. So when these n's cancel, I'm left with 3 n's, just like I was here, but now they're on the bottom of the fraction. So this is 1 over n to the 3rd. Let's take a look here. Look, I have this whole fraction and it's being taken to the 3rd power, but I notice I can actually simplify inside the fraction before I take it to the 3rd power. Okay, so I'm going to go ahead and simplify inside the fraction. So notice what I'm doing. I'm going to bring the fraction over. I'm going to do this. Okay, now I'm going to look at the numbers first. 5 over 3. Can I simplify? No, there's no number that divides by both 5 and 3. Bring it over. Okay, I did this. I'm just going to mark it for myself. Can I simplify this? Oh, yeah, I can simplify that. Look what this is. This is 5a's over 3a's. Look, cancel, cancel, cancel. I'm left with 2a's on top, so this is a squared. Can I simplify this part? Yeah, absolutely. Look, that's a b over 4b's, so when I cancel a b, I'm left with 3b's on the bottom. Okay, now I'm ready to take this to the 3rd power. Okay, and again, my favorite strategy is just to write it out. Okay, now look, you can do this where you're just like pretending. This is what I like to do because I'm kind of lazy. This is to the 3rd power. That means I'm multiplying it by itself 3 times. Okay, I'm not going to write it. I'm just going to pretend that this says 5 times a times a, and this says 5 times a times a. This says 3 times b times b times b. This says 3 times b times b times b, right? I'm just going to pretend. So let's multiply. 5 times 5 times 5. That's 125. A times a times a times a times a times a. That was 2a's 3 times. That's a total of 6a's. This was 3 times 3 times 3. So that's 3 times 3 is 9 times 3 is 27. This is b times 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 b. That's 3b's 3 times. That's a total of 9b's. Last one. Again, this whole thing is going to be taken to the 4th power, but the first thing I'm going to do is rewrite the inside part, because I notice on the inside part there's an exponent, which means, right, this is a fraction, and that this guy, just this guy, not the 2, not the y, just this part, is not happy on the top of the fraction. So we're going to rewrite this whole thing as a fraction. We're going to say, oh, the 2 is perfectly happy, and the y to the 5th is perfectly happy, but that x to the 3rd, now it's happy on the bottom, right? It was unhappy on the top, it's going to be happier on the bottom. So now, just like very much like this one, this is 2 times y to the 5th over x to the 3rd, and I'm multiplying it to the 4th power. So I'm multiplying it by itself 4 times. So let's just imagine this is 2 times 2 times 2 times 2. So 2 times 2, that's 4, times 2 is 8, times 2, it's 16. This is y times y times y times y. That's 5 y's times another 5 y's, another 5 y's, another 5 y's. So that's 5, 10, 15, 20 y's. And this is x times x times x, another 3 x's, another 3 x's, another 3 x's. So that's 3, 6, 9, 12 x's. And there's my answer.